Right, this is a exam question in which you need to calculate the temperature at which this reaction becomes feasible. So it's given you the equation and the enthalpy value, and it's also given the change in entropy. So if we look at this, first of all, we need to write the equation out. So change in Gibbs free energy equals the enthalpy change minus the temperature times by the entropy change. So first thing I need to do is convert this entropy change into kilojoules per Kelvin per mole. So I'm going to divide by 1,000. So my entropy change is minus 180 divided by 1,000. The temperature is what I'm trying to work out, and my entropy change from the question is minus 49 kilojoules per mole. So it wants to calculate the temperature at which the reaction becomes feasible. So the reaction becomes feasible when Gibbs free energy change is 0. So because of that, I can substitute that 0 value into my equation, and it becomes 0 equals delta H minus T delta S. So I can take this minus T delta S. If I add T delta S to both sides, that gives me T delta S equals delta H. And then I'm trying to work out the temperature, so I want to isolate that. So if I divide both sides by delta S, that gives me temperature is enthalpy change divided by the entropy change. And if I look at what I've written here, that's minus 49 divided by minus 180 over 1,000. And if I stick that into my calculator, that gives me 272, and remember that's in Kelvin.